This is AP Calculus Practice Exam 1. In Part 4, we will begin working on the multiple choice questions, which are considered calculator active, so we will be using our graphing calculator as needed. If you have not yet watched Parts 1 through 3, you should definitely do that first. So either click the link that appears in the upper right-hand corner, or find the link in the description. The graph of function f is shown in the figure above. For which of the following values of x is f prime of x positive and increasing? First of all, we know that f prime will be positive when f is increasing. Graphically, f is increasing when it is rising from left to right. So f is increasing from here to about here, and then it's decreasing for a while, and then it is increasing again through here. So in these two zones that I just colored green, f is increasing, which means that f prime is positive. So we've taken care of that. Now, where will f prime be increasing? F prime is increasing when the original function f is concave up. We have already narrowed our answer choices down to the highlighted sections of the graph, so which of these two sections is also concave up? Well, this first piece is concave down, while the second piece is concave up. So the answer is going to be point E. But let us review the thought process that led us to the answer of E. We wanted to find the value of x at which f prime is positive and increasing. We found that f prime at E is positive because f is increasing at E. And we found that f prime is increasing at E because f is concave up at E. Let f be a function that is continuous on the closed interval from 2 to 4, with f at 2 equals 10 and f at 4 equals 20. Which of the following is guaranteed by the intermediate value theorem? The intermediate value theorem told us that if f is continuous and if f at a is less than k, which is less than f at b, then there is a c in the interval from a to b where f at c is equal to k. In other words, if k is between f at a and f at b, then f is equal to k somewhere. Looking back at the problem, we have two values of the function. So this is like f at a, and this is like f at b. So the intermediate value theorem guarantees that if k is between f at 2, which equals 10, and f at 4, which equals 20, then f equals k somewhere. So which one of these answered choices mentions a value between 10 and 20, and then says that f will equal that value somewhere between 2 and 4? The answer is A, which says f at x equals 13 has at least one solution in the open interval from 2 to 4. So notice, option A is mentioning this value between 10 and 20 and saying that the function will equal 13 somewhere on this interval. Option B also mentions a value between 10 and 20, a value of 15. Why is this not the answer? Option B says that f will equal 15 specifically at x equals 3. The intermediate value theorem does not tell us that f will equal 15 right at 3, only that f will equal 15 somewhere on the interval between 2 and 4. The graph of y equals e to the tangent x minus 2 crosses the x-axis at one point in the interval between 0 and 1. What is the slope of the graph at this point? When you heard the slope of the graph at a point, I hope you jumped out of your seat and said, "Derivative!" So here is our strategy. First, we will find the point where the graph crosses the x-axis. Then we will evaluate the derivative at that point. This problem is calculator active, so let's go ahead and type this function into our graphing calculator. Hit y equals and type in the function. Before hitting graph, let's look back at the setup of the problem. Notice that we are only interested in the interval between 0 and 1. So I would suggest adjusting the window accordingly. Hit the window button, and let's let x min equal 0, and let's make x max 1. Now hit the graph button to see what we have so far. We want to find the intersection point where the graph hits the x-axis. There are two ways to find it. I'm going to show both of them to you now. One way is to hit second trace and use the 0 function. This finds x-intercepts. So option 2, we do left bound, so just make sure you are definitely to the left of the x-intercept and hit enter. Now it asks for a right bound, so use your right arrow key to move yourself to the right of the x-intercept somewhere and hit enter. When it says guess, I just like to move as close as possible to the x-intercept and hit enter. So this is the 0, the x-intercept that we are looking for. Let's store this into a letter of our calculator. So hit second quit and hit the x value and the store button, and I'm going to put this into alpha A. That way, if we need this value later, we will have access to all of these beautiful decimals. But first, let me show you the other way of finding this answer. Go back to y equals. Some students get confused by the whole left bound, right bound thing that I just did. The way around that is to graph the x-axis itself by typing y equals 0. So hit graph again. So now you see the x-axis is shown in red. Instead of using the 0 feature, hit second trace and let's just find the intersection between these two graphs. So option 5. Some students like option 5 better because there is no left bound, right bound. You just come close to the point of intersection and hit enter 3 times. Enter, enter, enter. And you get the exact same value. So if you're uncomfortable with left bound and right bound, this is the way for you. Step 1 is now complete. The graph crosses the x-axis at a equals 0.606, etc. Time for step 2. We need to evaluate the derivative at x equals, and I'm just going to say a. We can use the calculator for this. To evaluate a derivative, choose Math and then option 8. We are doing dy dx. Right here, I could type in the original function, e to the tangent x minus 2. But I already typed this into y1. So instead of retyping the function, I like to hit vars and then switch over to yvars, and then I will hit enter and choose y1. So this is me taking the derivative of whatever I have typed into y1, which is the main function from this problem. Now I want to evaluate at 0.606111937. You can either type in all of these numbers right here, or since we stored this value into letter A, we can just go alpha A instead. Kabam! This is the answer, 2.961 if you round up. So the answer is D. Just for fun, here's what it looks like if you type in everything the long way. Same answer. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle at time t is given by a of t. Which of the following gives the average velocity of the particle from time t equals 0 to time t equals 8? We have learned two different formulas that include the word average. So we have to decide, are they asking us for the average rate of change of velocity or the average value of velocity? The average rate of change of velocity is given by this formula, while the average value of velocity is given by this formula, which I often describe as integral divided by interval. It is almost impossible to talk about average rate of change without using the words rate of change. On the other hand, when we say average velocity, it means the same thing as average value of velocity. So this is the formula that you should be using. Dividing by 8 minus 0, in other words, dividing by 8, is the same thing as multiplying by 1/8. So the answer is B. The graph of f prime, the derivative of function f, is shown above. Which of the following statements must be true? As we look at each statement, we will be referring back to the graphical relationships between f, f prime, and f double prime, so make sure you have this chart memorized. Statement 1. F has a relative minimum at x equals -3. Our favorite way of finding a relative min or a relative max is to make a sign chart of f prime and then see if it changes from positive to negative or from negative to positive, which tells us if we have a relative max or a relative min at that particular value of x. But we don't need to make a sign chart because all of that information is right in front of us on this graph of f prime. For example, we are trying to analyze the point x equals -3. But to the left of -3, f prime is below the x-axis. So f prime is negative on the left and it is positive on the right. If f prime goes from negative to positive, it means that the original function f goes from decreasing to increasing. This tells us that we do have a relative min at x equals -3. But again, we did not need to make a sign chart, we could just read it right off of the graph of f prime. But so far, we know that statement number 1 is true. Statement 2. The graph of f has a point of inflection at x equals -2. I think they are trying to fake us out on this one, because if you look at x equals -2, we see a beautiful point of inflection right here. However, this point of inflection is on the graph of f prime, not the graph of f. If the graph of f has a point of inflection, it means that f changes concavity. It either changes from concave up to concave down or vice versa. But if f changes concavity, it means that f prime will change direction, either from increasing to decreasing or from decreasing to increasing. So let's look at the graph of f prime and see if we see a change in direction at x equals -2. We can see that f prime is increasing from -infinity to -2, and then it just continues increasing after x equals -2. So the graph of f prime does not change directions at x equals -2. Therefore, the graph of f does not have a point of inflection. Statement 3. The graph of f is concave down on the interval from 0 to 4. Wherever f is concave down, our graph of f prime should be decreasing. So let's look back at the graph of f prime and see if it is decreasing on the interval from 0 to 4. We can see that the graph of f prime is indeed decreasing on the interval from 0 to 4. So yes, the graph of f is concave down on this interval. Since only statements 1 and 3 are true, the answer is E. Water is pumped into a tank at a rate of R of t equals 30 times 1 minus e to the negative 0.16 t gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water, to the nearest gallon, is in the tank after 20 minutes? First of all, if there are 800 gallons of water in the tank when the pump is turned on, and we are pumping water into the tank for 20 minutes, obviously, after 20 minutes, we will have more than 800 gallons of water in the tank. So we can eliminate options A and B immediately. Here is the key concept that I want you to memorize. The integral of a rate from A to B will always be the change in the amount from A to B. Again, remember, the integral of a rate is equal to the change in the amount. So, since R of t is the rate at which water is being pumped into the tank, the integral of this rate from 0 to 20 will be the change in the amount of water in the tank from 0 minutes to 20 minutes. In other words, this expression gives the amount of water pumped into the tank from 0 minutes to 20 minutes. Be careful, the question is not asking how much water was pumped into the tank during this 20-minute interval. It is asking how much water is in the tank after 20 minutes. Therefore, we must include the extra 800 gallons of water that was in the tank already when the pump was turned on. This expression gives the amount of water in the tank after 20 minutes. It is the initial 800 gallons of water that was already in the tank plus the amount of water that is pumped into the tank from 0 minutes to 20 minutes. Now it's calculator time. We need 800 plus, so start out by simply typing 800 plus. Now we want the integral from 0 to 20. For that, hit Math 9, and we are integrating from 0 to 20. Now it's time to type in the expression for R of t. 30 times the quantity 1 minus e to the something. I have no memory. So 30 times the quantity of 1 minus e to the something, negative 0.16 t. So have to use this minus sign, not this one. So negative 0.16, and the calculator forces us to use x instead of t. Be careful right here at the end. Even though you see a parenthesis right here, we need another one. Notice how we have sort of two parentheses at the beginning, and we need two parentheses at the end as well. And seal it off with a dx. And that's it. This is the answer. So to the nearest gallon, 1,220. So the answer is D. If f prime is equal to this expression, then f has a local maximum at x equals which of these? If we want to see where f has a local maximum, all we have to do is make an f prime sign chart. If f has a local maximum at a particular point, then at that point f prime will go from positive to negative. To make an f prime sign chart, we need to find out where f prime is equal to 0. This is calculator active, so let's type this equation for f prime into the calculator and find the x-intercepts graphically. So hit your y equals button and type in the expression for f prime. If you're wondering why I typed it into y2 and not y1, I always put f prime on y2. It's just a habit I have that helps me keep track of which function is where. Also, for this problem, I'm going to use the method of finding the x-intercepts, where I graph the x-axis itself. That's why I'm typing in y equals 0. That way I can just hit enter, 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 instead of doing left bound and right bound. So let's hit zoom 6 and see what we have. Okay, interesting. So I see that we have these three x-intercepts. Let's find them one by one. So I'm going to hit second trace intersect, and I'm going to go over close to the first one, and because I have the x-axis graphed, I can just hit enter, enter, enter. So the first one is negative 2.314. Write it down somewhere. Now for the second one. Second trace, intersect, and slide on over to the second one. And hit enter, enter, enter. So 0.350. Write it down. 0.350. One more. Second trace, intersect. Slide over to the third point of intersection and hit enter, enter, enter. 1.234. So here we go. We are making this sign chart. Let's take all of the values at which f prime equals 0 and put those on the number line. Now we need to figure out whether f prime is positive or negative in each interval. We can find that easily just by glancing at the graph. So to the left of the first x-intercept, f prime is below the x-axis, so it starts off negative. So we're negative in this interval. Between the first two x-intercepts, f prime is positive, above the x-axis. So it's negative, and then positive, and then it's going to be negative again between the last two x-intercepts. And then, of course, it's positive at the end. We are looking for the x value of a local maximum, which means that f prime needs to go from positive to negative, which would mean that the original function f was increasing and then decreasing. So, okay, f prime goes from positive to negative right here at 0.350. So the answer is C. However, let me point out that we did not have to make this whole sign chart. I did all of this really for instructional purposes, but on the actual AP exam, you would just say to yourself, okay, I want a local maximum, so that means I need to see where the graph of f prime changes from positive to negative. So you would graph f prime, but simply look at the graph and watch for where it goes from positive to negative. So where does it go from above to below the x-axis? That happens only right here. So go ahead and find the location of only this x-intercept, which turns out to be 0.350.